Hey everybody, welcome back to HPC Tech Shorts, the engineering water cooler here in AWS. I'm here with Charlie Gruenweld in Boulder. Hey Charlie.
Hey, how's it going?
Not too bad. Charlie is a principal engineer in our engineering organization. That's his groups are responsible for building ParallelCluster and Engine Frame. And today, what's really cool, Charlie's come along to show us a thing called PCluster Manager. I think that's the right name, isn't it? Yeah. Mm-hmm. ParallelCluster Manager basically just puts a complete skin on the front of building, administering, designing clusters with ParallelCluster. It uses all of the APIs that ParallelCluster has constructed in the last, particularly in the last major release in ParallelCluster 3, and it uses a bunch of other stuff that the cloud has got available. I think it's actually better if we just show everybody, Charlie, right?
Yeah, let's jump in.
There it is. Okay. So walk us through now, for everybody's benefit at home, if you're wanting to follow along, we're starting here, which is the AWS samples GitHub repo where PCluster Manager lives. So
cool. So let's see, we're at the kind of home page for the source for ParallelCluster Manager. Like Brendan mentioned, this is built on the ParallelCluster API, and our README has the basic documentation for how you install it. It's actually not very complicated at all. We have the kind of step-by-step process you can look through and follow on your own, but at a high level, we have these one-click launch templates for CloudFormation. So you choose the region you want to deploy ParallelCluster to, and that'll bring you over to a stack creation page. And here,
so this launches you inside your own AWS account at the CloudFormation stack creation page. Got it.
Yep, that's correct. So we have a few very basic parameters here, the name of the stack, which you can leave as is. And kind of what's important would be to change the username here.
Right.
And this is setting up an administrator account so that the ParallelCluster Manager is locked down when it's installed. So otherwise, we can leave all the settings as default. We accept these acknowledgements, and then we click the Create Stack button. So this is going to launch the stack creation process, which will deploy ParallelCluster Manager on your account, as well as the ParallelCluster API that the PCluster Manager is going to talk to.
So my first question, so when it's launching PCluster Manager, it's kicking off some infrastructure build using a CloudFormation template so that it can offer this GUI. What's the stuff that's running in the back? Is it expensive, or is this like, 1 cent per hour kind of?
That's a great question. So the design of PCluster Manager is pretty similar to the design of the ParallelCluster API, in that it's supported by an API gateway and Lambda functions. You kind of pay for what you use, and it's really pennies for some requests.
Pennies. In fact, most of that's probably going to fall into the free tier, I would wager.
Yep.
So okay, cool. Pretty simple.
The front end does do some polling to allow live updates, but it's pretty cheap to deploy this.
Cool.
So this deployment does take a few minutes, so I'm going to skip to one that's been already deployed here. And so if we look at the outputs of one of these, we'll get a URL that we can copy and paste into our browser, and that's going to bring us to the front end. A part of the deployment process is going to be you'll receive an email with a password. So when you go to this URL, you can log in using that temporary password and set up your administrator account. So when we go to this URL, we will see something that looks something about like this. For me, I have a few clusters deployed. Besides the account information, PCluster Manager is all stateless, and so it's interacting with all of the clusters the same way that the command line interface does as well.
So if you had a bunch of existing parallel clusters running inside your account already, this is going to recognize that they're there and scoop them up into the UI.
Yep, exactly. So if you create clusters here, they're available to the CLI. If you create them on the CLI, they'll be available here. For new users, this is going to just be a blank list. And so the first thing you're really going to want to do is to create a cluster. let's see, the first thing you'll do is name your cluster. This is kind of an ID. And one great thing about having a UI here rather than constructing a YAML on your own is that we're able to provide some kind of like guardrails and feedback. So we can just see right away if I create a cluster and there's a name conflict, then I'm not going through some extended process before finding those errors. I can kind of address them right away so that at the end of this process, I'm ensured that my configuration is valid.
Right.
So the next setting that we have is this configuration source. And this is another neat thing that we've been able to create, kind of based on the fact that our configuration file is in the YAML format. It means we're able to kind of consume that in different areas. And so one way that we're able to do that inside of PCluster Manager is it allows us to kind of have a few different pathways for creating a cluster. So in looking at these, we have the wizard interface that will just basically start you with a blank cluster configuration. But there's also this template, and that's something that we've really seen beneficial kind of in the field, and some of our solution architects are working with their customers, is this represents a cluster configuration or maybe even a partial cluster configuration that's kind of filled out for an appropriate use case. And then you'll still walk through the wizard, but you'll be able to change settings like setting the VPC or changing the queues to kind of adapt that template to your custom needs or applications. So I'll go to my home directory and go to cluster configs. So I just have a dialog box here that's standard choose file option, and I'm choosing a CFD. So after I choose that file, it's kind of representing or providing a lot of the defaults for these configuration options that we choose for our cluster. So we kind of start at a pretty high level, which region things are running in, the operating system to use. There's the option to choose a custom AMI file.
So you got AL2, CentOS 7, Ubuntu, and a couple of versions of Ubuntu. That's cool.
Yep. Cool. So for this particular configuration, I don't need a custom AMI, and it's already chosen the appropriate VPC. Again, that was kind of in the defaults in the file, and that's again where the cluster is going to be running. And we have this refresh AWS config, and so that's if you get to this screen and you realize that you don't have the VPC that you want this cluster to operate in, you can create that externally, hit this refresh AWS config, and that VPC will then pop up in this dialog box.
What if I didn't have a VPC at all? Would I just be following the wizard process at this point and it'd create a VPC for me?
Yeah, you'll need a VPC external to this. The wizard isn't really creating a lot of external resources, but if you have a default VPC, you could use that for your configuration.
Right. Okay, cool.
Okay, so moving along. Now we have gotten to the head node configuration. We can choose the instance type. And again, here we have a nice drop down to kind of give us some of the stats on what the instance is. For this particular cluster and demo, I have a kind of a larger instance because I'm going to be doing some visualizations. And again, that was the
instance, right?
Key pair, that's something, again, that's in my account. I can choose from a few different ones. This one will provide an SSH access to the cluster.
I can encrypt my root volume if I wanted to, pick out which subnet I want to use.
Yep, exactly.
And actually, I could even pick a bigger volume size for the root disk on the head node if I wanted to.
Yep, that's right.
So if I know that I've got a crap ton of data, that's a metric crap ton of data that I'm going to need to put on the head node, I could actually do that if I wanted to.
It's important to note here that I'm enabling the virtual console that allows us to access a web-based shell interface, and this virtual desktop provided through DCV that provides us a web-based remote desktop. And so those are two options that I want for this cluster and this demo. So the next thing that we can configure is the storage for the cluster. This is an important consideration for pretty large clusters, in that you'll need to share storage between your compute nodes, and there's a lot of different configuration options for each storage. So this one's set up to use an existing FSX for cluster file system.
So they'll actually find the FSX file systems you've already got running in your account.
Yep. It'll find those and then provide it in this drop-down box, so you don't have to go look up the ID or anything. It's just kind of all there, ready to go. If you want to use it, you click it, it'll be the right value.
And if I didn't want to use FSX, if I just wanted to have something really simple like EFS or share it off the head node,
you can, because I already have an FSX file mount in this cluster configuration, the UI knows that there's a limit to how many FSX file systems you can have. So now that I'm choosing to add an additional storage, FSX isn't even an option. So there's no kind of
got it.
Potential.
But if you remove the FSX mount, you could then add maybe an EFS. You could
add and we can actually support FSX and EFS. And so here we kind of see EFS is set up. It's not using an existing file system. So instead, it's providing the additional options that you can choose. And so if you're not using an existing file system, ParallelCluster will create the file system and attach it. But that also means that file system's kind of life cycle is dependent on the cluster. And so if you delete the cluster, you'll be deleting the file system. So that's why I've chosen to have this kind of external FSX file system for this configuration.
Yeah, that makes sense.
So now we get to the queues configuration. And so there's a handful of different ways that you can set up your queues.
I mean, for people who are unfamiliar with ParallelCluster, you can define a whole lot of different queues on a ParallelCluster. Each of them could have different types and classes of nodes in them. And, this is kind of familiar to people when they design clusters on-prem. You typically have, a whole bunch of thin nodes, your commodity compute nodes, and then you might have some fat nodes with a lot of memory. You might have some GPU nodes. You might have some other nodes with some special storage attached. You can do all of that, but this is like pick and mix at the movies, where you just go in and actually just choose whichever one you needed at the time and just put it in the bag. This is pretty cool.
Just to provide an example, if I had a different queue that had some different use case, I can just click that add queue button. I can choose how many nodes that it'll have by default, or kind of the static nodes, and then how large will allow it to elastically expand to depending on the needs of the job. Choose the subnet that this queue belongs to, the instance type, just like the head node. So all of the queue configuration options, and then whether or not you want EFA enabled. And again, that toggle is going to be dependent on the actual instance type. So finally, we have the cluster configuration. This is kind of just meant to provide a representation for those power users that are pretty familiar with our cluster configuration, or if there's something that's not provided in the UI, you can go in our documentation and kind of get some familiarity with this format and make some changes to this file if you'd like to make any last minute changes to how it was generated.
So you hit create here, and you're going to get a cluster in like 5 minutes or so, right?
Yeah, that's right. For me, I like to hit dry run first, just to kind of make sure that there's no issues on the back end. And so after I hit dry run, I've got this nice green checkbox that's telling me it's gonna successfully create this cluster when I hit create, but it also provides this warning about kind of DCV being exposed to the world, and a recommendation. If we had chosen, that's the default, and so if we had chosen a specific IP address, then that there would be a configuration option right under this DCV setting that would be filled in with that IP address, and that would allow that warning to go away. So once we're comfortable with the cluster configuration, we can click create, and that'll send the request to the backend, and it'll kind of get validated, and then it'll start creating the cluster. And again, this is backed by a CloudFormation template, so ParallelCluster will start creating that. And then we can see on our list here's our CFD
create in progress
that we created. The creates in progress, and this is all live updating. So when the cluster creation is complete, this will kind of show this green create complete status. And let's see, we have at the top of this window here, I have the kind of a handful of actions that I can perform on this cluster. So one's a shell, and so you remember I enabled the virtual sessions and virtual desktop. And so if I click the shell button, this is going to use the AWS Systems Manager, and I get a login, and now I'm connected to the head node. Let's actually do a S batch with the N64, and we can just run
stick a job in there. Yeah. Okay.
We'll just wrap the ID command. That's going to give me kind of the username and groups this user belongs to. So I can just fire off a job, directly from. What's crazy is I've actually seen someone create and manage a cluster all from an iPad. And so let's go back and look at what this cluster looks like in our in our UI. Now we
All right, now you see, look at that, compute nodes.
Yep, we have all of the compute nodes that have been spawned in the background just as the result of running that ID job. So again, we're kind of specified a cluster configuration. We ran a job that required 64 nodes. Those were available dynamically. ParallelCluster spawned the nodes, and then ParallelCluster Manager, this front end, provides this nice interface for seeing the state of the cluster, the state of the nodes. If you click one of these links, it will jump into the AWS console with that instance selected, so you can see all of the more detailed properties of that instance inside of the AWS console.
Cool. And what if I wanted to get a DCV session? Let's exercise that button there, because
so
lots of people are going to think that this is just voodoo.
For a lot of use cases, we also have a front end kind of need for.
Let me interrupt you there. What's happening here, folks, is it's actually ParallelCluster Manager has actually spawned the DCV. It's using the DCV Web SDK to actually create a DCV virtual desktop session inside a web browser tab that's connected to the head node of the HPC cluster at the other end. And all of that kind of happened in a couple of seconds.
Yeah.
And for most people who are using traditional HPC clusters elsewhere, in other places, I feel so sorry for you. You don't have this. You can't just like say, oh, I want to spin up an entire HPC cluster and get head node access visually so I can run some graphics applications. You just can't do it quite this easily. So show us ParaView. Show us a graphical application running in here.
I'll run ParaView here. Close the dialog box, and I can open up the just kind of pull out some example. And then
this is a complete Linux remote desktop running on the head node of the cluster with a serious GPU attached to it. It's running over the wire inside a web browser. And that is very cool. This is actually this is very similar. This is all the same technology that Netflix uses to actually enable their, remote access to all of their design studio and like video editing and CGI special effects studio machines that they run in the cloud for all of their editors around the world. This is how they distribute their workforces, is using DCV in a web browser like this. This is amazing.
It's truly an amazing experience. I don't think the video quite does it justice, but the fact that, again, you could be doing this on an iPad and all it's doing is really rendering this front end, and you have the access to a really beefy GPU on the back end that's kind of helping do all of this.
I could be doing this on an iPad from a pub.
Exactly.
We're going to have to do that. We are going to do HPC in the pub one day, and we're going to do I'm going to take Neil, and we're going to do CFD in the pub.
Go to edit a cluster, and again, there's certain aspects of the cluster that won't be editable, so those will be grayed out, so no mistakes there. But if we go on and we want to, say, change the compute queue to add more nodes because we want to do a bigger experiment, we can just change that number right here. We hit next, and just like the flow before, instead of create, we have an update operation. So
this gets me to, I think, probably the last thing that we'll say before we have to sign off today, which is that, this is a really cool example of how we increase the productivity of people who use HPC resources. Making CPUs faster, definitely a goal. Making networks lower latency and higher throughput, definitely a goal. But one of the greatest piece of low-hanging fruit in the HPC universe is to make the users more powerful and more successful. And this has just done that. So, Charlie, thank you for this. Really appreciate it. There's a huge amount of goodness here. I'm going to put the link up again for everybody who's watching. This is the place to go and find those launch buttons. Literally, you just go to this GitHub project whilst you're logged into your AWS console, and clicking on one of those launch buttons will launch all of all of the infrastructure to give you this UI inside your own AWS account. You can immediately start managing the stuff that you've got or building stuff that you don't have. So very, very cool. And for anybody else out there, if you've got other things that you want to see us cover on Tech Shorts in the future, DM us on Twitter. DMs are open. We'd love to hear, and we'll see if we can work out how to find one of our internal experts to show some stuff. Charlie, I'm going to have you coming back to do another talk on this soon because there's a lot more to cover. I think we've only just scratched the surface.
Great. Thanks for having me. Really appreciate it. If any